You see my screen?
Yeah.
Perfect.
No.
Now I was asking them. Sorry. You should see it in a bit.
Yeah, you're good.
All right. Good to go?
Yeah.
All right. Finally, we made it. 9 minutes. Cool.
Oh, not sure. Go ahead,
Sorry?
plug in right there.
Oh, that's what I was missing. All right. So the talk is called, I'm sure you saw it on the schedule, but now you also see it here, deploying stateful real-time services to the edge. It's a little mouthful. I was trying to come up with a shorter one, but I couldn't. Hi, I'm Dev, and I'm a dev. That is actually my name. That's not an abbreviation. I know I get that question a lot. And yes, the irony is not lost on me. I work as a software engineer at Smart Data. We're a consulting agency based out of Ohio. And I'm also a content creator. So if you like my talk today, you might also like some of my YouTube content and some of my shit posting on Twitter. Sorry, X. So again, serverless, I asked about it earlier. It's kind of awesome. We really like serverless because it allows us to focus on our application logic, what makes our app, our business unique from our competitors, and the things that actually excite us, and not all that boring red stuff. Because that a lot of those things are kind of the same between every application that happens to be on the cloud. It takes a lot of time. It's not something that should be hidden from us. It shouldn't be a black box. But we can always dig into those details if we want to. But when we build in a serverless way, those details are not shoved into our face. They're not something that we are forced to deal with all the time. Now, there is a little bit of an operational cost that comes with serverless. But if you can take those time savings and put that into building a better product or shipping faster and getting your features into the hands of your users much faster, then that higher cost is always going to be worth it. But on the complete other end of the spectrum, you can just build monoliths, which are single applications deployed to single instances. It's more familiar. We've been building like that for a while. It gives us complete control of the infrastructure that our application runs on, and it gives a lot of capabilities that we want. But obviously, there are some trade-offs that we'll get into in a bit. Let's talk about state for a second. Generally speaking, there's two kinds of state that we have to deal with when we are building apps. We have persistent state. This is our files, our databases, our cloud buckets, anything like that. This is data that is saved on the disk. It's durable. It has backups. It's redundant. So if something goes down, you still have access to it some other way. And usually, you would access this state over a network. Now, if you're deploying to a single instance, you might be accessing it locally. You might have a local file system. But normally, it's over a network. And you have to go over the internet or some sort of local subnet to access that state. In-memory state, on the other hand, lives in memory. It's your in-memory data structures, however you want to represent it. You can access it almost instantly compared to persistent state. But the problem with it is it's ephemeral, it's volatile. As soon as it's the process or the server that the state lives on, if that dies, or if it restarts, or if you redeploy with a different code, your state is gone. You no longer have access to it. But there's a lot of reasons why we want in-memory state in our application. It's much faster to access in-memory state than it is to access any sort of persistent state. So you can do a lot of low latency things with in-memory state. It also removes all the concurrency handling things. So you don't have to worry about what a different request or a different user might have done with the state in middle of your request. You don't have things like transactions or locks or any of those fancy database features that you might be using. So from this point on, I'm going to talk about in-memory state as like just state. When I talk about stateful apps or state in our apps, I'm only referring to in-memory state and not persistent state. So I talked about monoliths. Again, the point is that you have access to all the capabilities, which includes in-memory state. And it's also a very simple way to build things and to deploy things. But it doesn't scale. You are limited by the physical constraints of the server that you run your things on. This might not matter to you, to your specific project, your specific business. You might be completely fine with a single server deployment. But it's the limitation of that architecture that we have to acknowledge. On the other side, serverless allows you to scale almost infinitely. There's a lot of success stories of big companies that handle loads and loads of Black Friday traffic on these serverless providers very seamlessly without breaking a sweat. And it's also very simple for the same reasons we talked about. You don't have to deal with those technical DevOpsy things up front. You can choose to deal with them as you want. But you lose access to in-memory state. Suddenly, all your data has to live in these external infrastructure things like databases, like queues, like event logs, or file systems. And it's because serverless tries to be completely stateless. So this is kind of what it looks like. I'll probably switch to a more less exciting, but probably more clear visual here. The point is that the blue is your application logic. This is your code. This is your services. Every time a user hits one of your applications or one of your application servers, it has to talk to these external databases, external data stores before it can do anything. You don't have any state that lives in your application, which means if I do something here, it first has to go over to my data stores, and your database might be replicated and distributed to handle large data loads. But that's not something you necessarily need to worry about, because that is handled within the database or within the provider. But there's still going to be some network latency, not only between your service and your database, but internally within the database distribution before some other user can see what you did. On the other side, we have something that I like to call sharded architecture. It's not an official name. That's something I had to come up with. But the point is that you can have state within your application servers instead of outside of it. So now when I do something here, it only needs to update the external state. But then it also needs to send some messages to all your other services that you might be hosting so that they can update their own state. And then the other users are able to see what you did. Now, when you build your apps like this, first of all, today there's no real way to do this with serverless tools. You have to manage all the state yourself. You have to figure out how you're going to synchronize the state between all of your different servers on your own. And then you also cannot just have all the state replicated to all your servers, which means you probably have to figure out how you're going to break them down into smaller bits that can live on these different servers. And then you need to figure out how they're going to live, like how you're going to distribute them between different servers. And then if you have multiple users that might be looking at the same piece of state, do you send them to the same server, or do you send them to different servers, but then there's a latency between them? So the point is that there's a lot of complexity when it comes to building like this, which is why they're not simple at all. It requires a lot of effort to build and scale stateful systems. Just ask anyone who builds multiplayer games or apps like Figma or Notion, anything like that. They will give you both stateful and scalable properties, which is what we want out of these systems. But again, they're not simple to build. So what if we could take all that stateful sharding logic and figure out some way to make it serverless, or offer a serverless primitive that encapsulates all of that, just like how serverless functions encapsulate scaling logic? What if we had serverless objects instead of just functions that not only have your behavior, but have your state internal to them? And if you have multiple users that need to look at some piece of state, they simply connect to the same object instead of connecting to the same function. That's the idea behind what I'm calling stateful serverless. Again, it's not really kind of an official name. It's just something I had to come up with. But if we are able to do something like this, we get everything that we want. We have something that's stateful, we have something that's scalable, and we have something that is very simple to build or simple to implement. This is the premise behind Cloudflare Durable Objects. This is a recent product from Cloudflare, and PartyKit is an SDK that's built on top of it to allow building things in a much simpler way. So this is what I'm going to demonstrate today. So here, I'm going to zoom in a bit. Let's remove that. Do I have this running? Oops. npm run dev. So I have a little game that I've built here. It's built with Solid, but it's similar to React. So most of the code should feel and read familiar. Just waiting for this to start running. It usually doesn't take that long. OK, there we go. So this is what it looks like. We're going to create a game room. And it's a simple emoji game where I click somewhere and my emoji is there. So it'll give me 1 more second before I can click again. So I can keep clicking. And once I have 5 of these in a row, column, or diagonal, I win. That's as simple as it is. I don't have this deployed. I couldn't figure that out in time. But I'm probably going to have this deployed version of this at some point. So if you want to see that, there's also going to be an open source repository with the code. So let's try to see if we can make this game multiplayer. I'm going to quickly go over the code here. First, we have some state. Create signal is basically like use state in React. So we have our board. We have our cooldown, which is 1 second for now. We have the current emoji, which has been assigned to us, which in this case is this palette. We generate a unique ID for when the player joins the room. We're going to assign a unique emoji. We're going to talk more about this in a bit. And this is the function which gets called every time you click on a cell on the board. We're basically just going to check if it's empty and if the cooldown is 0 and if the game is not over already. Let me actually, I forgot to disable this extension. It's very annoying. Disable, please. All right. Give it a quick restart. All right. Yeah, so we're going to get the index of the cell that we have clicked. We're going to set it to this the current emoji that's been assigned to us. We're then going to check win, which is going to see if we have 5 of the same in a row, in a column, or diagonal. And if that's the case, we're going to set the winning cells. Like here are the cells that won me the game. If not, I'm going to start my cooldown timer. So in 1 second, it's going to allow me to click again. Down here, this is pretty straightforward. We're going to show a list of players, which right now there isn't any. It's just an empty array because it's not actually multiplayer. If the game is over, we're going to show the victory message. And if the game is not over, we're going to show this timer. And down here, we just have our game board, which is going to show our grid and all the emojis that have been placed in it. Pretty straightforward. Once again, I'm going to go back, create a new room. This time, we have the circus tent. Is that something? That's a circus tent, yes. So once again, if I do 5 in a row, I'm just going to click here again. These are our winning cells. So pretty straightforward. Any questions about the code so far? Or should we start making this multiplayer? All right, let's go. So the first thing I'm going to do is add some message types. So the first thing we need to know is we're using WebSockets because this is a real-time multiplayer game, which means we need to figure out what are the messages that are being exchanged between the client and the server. The first one here is the player joined message. So when a new player joins, we're going to tell the server, hey, I'm a new player. I've just joined the game. And the server might tell us back, hey, this is a new player that has joined. Make sure you show it in the UI. Same thing with the player left. Here's a player that has left the game. This is a player moved message. So this is the player, and this is their emoji, and this is the index or the place in the grid that they clicked on. And here are the winning cells if that was a winning move. And finally, when the first time we join the game, the server is going to tell us, here's the state of the game right now. Here's what the board looks like. Here are the players in the game right now. And here's if the game is already over, you can see those cells. So this is what the server is going to give us the first time we join. So these are just some TypeScript definitions for our messages. The next thing we're going to do is right there. So we're going to use this hook called usePartySocket, which comes from it's a little bit of a custom implementation, but it's basically this creates a WebSocket connection to our PartyKit server, which we're going to get more into in a bit. It's going to run on localhost 1999. And the core abstraction that PartyKit gives us is this thing called a room. A room is basically how we tell PartyKit which server we want to connect to. Each room is going to have its own private state in the cloud. And if two clients connect to the same room, they're going to see the same piece of state. And every time you change the room here, you're going to get a different piece of state. So we are going to use this ID here from the URL to decide which room to connect to. So if you go to the same URL, you're going to look at the same game room here. And by changing the URL, you're going to a different room. Then we have a function here that handles how every message that comes from the server. So you can see here, we can either receive the joined message, left message, move message, or a game state message. These are the messages that we can get from the server. And we're going to handle these messages here in our client. I'm going to add quickly another piece of state for players and set players, which is an array of all the players that are in the game right now. So down here, we're going to switch over the message type. Now, really, all of this is just normal JavaScript. We are not dealing with any special APIs here other than this room and this party socket, which is just a very small wrapper over the WebSocket web standard. So very simple. When we get a player join message, we add them to our players array. And when they leave, we're going to filter them out of our players array. Straightforward. Now here, when we get the player moved message, obviously, we're going to set that index in our board to the emoji that whatever that player was assigned. If the message also contains winning cells, which means the server decided that the game is over, we're going to set those winning cells so that we can show that on our board. Like, hey, the game is over. Here are the cells that won the game. And obviously, when we get the game state message, which is just set the state, I don't care what your state is right now, we're going to set our board, set our players, and obviously set our winning cells. That's it. So very simple. We have a function that handles all the events, all the messages that we can get from the server over WebSocket. We need to add a couple more things. So we're going to create an effect, which is the same thing as a use effect in React. Thank you, Copilot. So, or Amazon Q in this case. I don't know why I'm still using Amazon Q. Anyways, so when our WebSocket connection is ready, we're going to send a player joined message to our server. That's going to tell it, hey, here's a new player that's joined, and it's going to distribute that to everyone else. The next big thing is our server. So this is what our PartyKit server looks like. This is, again, if your serverless functions are just functions, your durable objects are just classes, and each object itself or each room is an instance of this class. You can see we have an onConnect, onMessage, and onClose. All we need to do is to implement these three. We also have an onRequest. You can send an HTTP request to a PartyKit server or a PartyKit room, but we're not doing that today. We're just doing WebSockets today. So let's get some types in here, which are our game state, and these are the messages that we can receive from the client. We only receive the moved message and the joined message. In here, we're going to initialize some state, which is our game state. It's an empty state of like, here just the list of players, and then our board, which is an empty array. When we connect, all we're going to do is send the game state down to our newest connection. And when the connection is closed, we are going to find the player that with this connection ID. We're going to remove them from our state, and we're going to broadcast this message, player left. So everyone who's already connected are going to remove that player from their UI. Finally, in our message hook, we are going to parse the message, and we're going to implement two other methods that are going to handle these specific messages. In here, player join. Oops, that's not what I wanted. There we go. So when a player joins, again, we're just going to set our internal private state with that message, and we're going to once again broadcast a player join message. This one is a slightly more complicated one, which is when a player moves, we are first going to check if it's a valid move. And if it is, we're going to set that cell on the board. We're going to check if it's the winning cells, and we're going to broadcast that player moved message to all our clients. Cool. So that's pretty straightforward. That's all we had to do in our servers was to handle the different types of messages, and that's all we need to do. The final thing we need to do in here is we have our handle cell click on the client side. We need to remove this logic from here and send a message to our server that gives it, yeah, that was it. There we go. We need to send our player move message to our server so that it can actually update the state. Let's get rid of this. All right, let's see if it works now. I'm going to hop over here. Going to refresh, and this still works. Let's open it in a new tab. Let's combine these two here. And the one thing I forgot was to send the list of players here in our player list. There we go. So now if I refresh here, you can see that we have the list of players. This one can add a balloon. This one can add a controller. And we can keep adding. We can keep adding a balloon here. And once there's 5, this one sees you won, and this one sees you lost. Now, all we had to do was simple logic on how to handle these messages. And we already have something that can handle hundreds or thousands or millions of users because it gets deployed on Cloudflare. And we already know that Cloudflare scales like crazy. That's all I had for the demo. I just have a couple of slides to very quickly go through, because we have to talk about why this matters on the edge. Well, actually, I don't have time to go through this. But the core point is that this way of building is very nicely compatible with edge compute or edge networks. So that's all that I'm going to talk about. Thank you. And if you do happen to build something like this, please share it with me.